Okay, good afternoon everyone. My name is Brandon Namey and I will be giving today's presentation on the invisibility cloak. Hoping today will be a fun and interesting subject for all of you, so let's go ahead and get started. Quick overview of the presentation. We will start with some background information and definitions. I will explain the overall design and how the machine works, run you through a quick example, and finally finish up with the impacts of this technology, and any questions you may have I will take at the end of the presentation. First off, if any of you have seen the movie Harry Potter, I am sorry to say this is not what we'll be discussing today. If you haven't seen Harry Potter, please do so immediately after this presentation. It's for your better good. Anyway, the cloak we'll be discussing today is far different from J.K. Rowling's version found in the Harry Potter series. During my research, I discovered two major groups currently studying the act of invisibility. One study was led by Professor Zhang, the other by a group of researchers from the University of Rochester. I will discuss their impacts later in the presentation. Now, what is invisibility? In short terms, invisibility is a trick of light. We see objects simply because light reflects off of them. Therefore, invisibility cloaks are designed to bend light around an object. For example, if Harry Potter wore this particular cloak, he would actually need to remain still. Some definitions that will come in handy. First, and most importantly, light rays, which is essentially an idealized model of light. In a more advanced term, a light ray is a basic element of geometrical optics. It is a hypothetical construct that, for any point in space, indicates the propagation of light. Now, on the other hand, surface waves are seismic waves that travel along or parallel to the Earth's surface. These are also known as elastic or electromagnetic waves. Okay, now let's discuss the design. The cloak is constructed of a 50 nanometer thick layer of magnesium fluoride, topped with a pattern of gold bricks measuring 30 nanometers thick. To put this into perspective, the average human hair strand is actually 100,000 nanometers thick, so these gold bricks are actually incredibly tiny. Now, how does it work? In this image, you are presented with light rays. As you can see, the light travels in a straight line to the viewer. When obstructed, the light can no longer reach the viewer, which is kind of common sense, and you guys know this. Invisibility systems, such as the one presented by Rochester, calculates the direction and position of the light rays so they can properly be displayed to the user. The researchers of the University of Rochester built the device seen in the current image. Researchers used 4 lenses as found in any regular lab. They found exactly what power of lens and how far away these lenses needed to be spaced. Background light is now focused on one point of one lens and diverges out, causing the light to bend around the object. As long as you are looking through the first lens, any object approximately 15 degrees from the center will remain hidden. Onto Zhang's invisibility cloak. In this image, you will notice a hill-like object. The red and blue lines represent the surface waves, like we discussed earlier. Currently, the cloak overlays the hill. Notice what happens if we were to actually remove the cloak. The surface waves scatter. This is because the object obstructs the path of the traveling surface wave. Here is an illustration of Zhang's invisibility cloak. As you can see, light is being reflected off the golden brick pattern. Even though the surface underlying the cloak is not flat, light still reflects off the object as if it were a flat mirror. The gold bricks reflect the light in such a way that the light phase and frequency are both preserved. Here's an example. Zhang's scientists wrapped a tiny, irregular-shaped object measuring about 30 microns across, or a bit more than a 100,000th of an inch. Shining a light with a wavelength of 730 nanometers, or near-infrared, they found that it reflected back almost perfectly. The light scattered from the cloak, which still bounced off the object, but without revealing where the cloak was. With the proper tuning of the gold bricks, it's not hard to make the reflected light look like anything you want. If the cloak were big enough, you could cover a tank with it and make it look like a bicycle, suggested Zhang. First off, I would like to mention these designs are not ready for nighttime sneaking around. If the cops show up to a party, you can't slap one of these on and sneak away without getting caught. In the future, however, researchers hope to find this technology very successful in many fields. In particular, for the military, in small scale, it has the potential to hide soldiers, and then on a large scale, it has the ability to hide objects such as like a tank, as suggested by Zhang earlier. Here are my references. And finally, if any of you have any questions, please comment below. Thank you for listening.